up to the idea and they understand how it is difficult to make this complex solution of education to get high results. They understand that they need a good curriculum with interesting exercises to keep children's interest, and in fact they need to invest a lot of money and time resources in making it in a proper way. From the other hand, one thing is to know something, another thing is to teach somebody else and especially establish a durable educational process. From the other side, there are toys on the market, robots from like entertainment clubs from entertainment, where children assemble robots from some blocks and then use some specific software of this robot. It's something like an extended toy. Maybe it's good for playing and for all this topic, but what children will gain from these clubs? They will understand how to use existing platform. After these clubs, children will just go, what they will gain? They will ask their parents to buy another toy of this company, because when it appears in the market, a new one, because they know how to use it. That's why these courses are rather short, like about 4 or 6 months. In some schools, it's extended to like 1 year, these platforms, because then children start doing the same things all the time. They have used all the options and then they lose their interest. So it's a closed hardware and software. So we are based on open source hardware and software. It's the only way to make children understand that technology is not a magic. They understand how it works, and they become not consumers and users of the technologies. Who are they now? But inventors, creators. And this is our serious mission. And if talking about the country as a whole, in a scale of a country, what happens now? Usually specialists grow up, the ones who can use some technologies and maybe software in a professional use. But again, they just become specialists and users of existing technologies. And usually this, for instance, some software for architects, it usually like belongs to foreign companies, and it's a proprietary closed license software. In a case if a license will be cut out, so a specialist will lose his job, and he will need to raise his qualification and to move somebody else, and the country as a whole will have technological problems. We have absolutely other concept. We grow up the ones who will create technology inside their country. And this is our serious mission. That's why we start from early age. So we are about serious education, not about playing, based on open source technologies. At the same time, we know how to establish this educational process from early age and making them reach high level of knowledge and skills. Further on, children will be able to get a highly paid job, or even become IT startup founders or co-founders. So even now we have such cases when children, it means that we have the signs that we move in a right direction. Children even now get some projects to make from some big companies. So I know the case where a child making some projects for 3D modeling projects for some big foreign company, and starting gaining even more money than his parents' salary. Or sometimes children help their parents' business, making web pages, mobile applications, and so on. So we have a complete solution to reach this, our aims. So we have a open hardware and open software. We have very detailed curriculum. We have teacher training, and we have a concept of international competitions, different types of competitions. So our curriculum, it's an overview of our curriculum. It's the biggest result of our scientific work, of our research and development work. So we have invested a lot of our own money and money of different grants and investors in making this curriculum, like more than $10 million. That's why it works good. And it took a long time to make it in such a way. So we take into account psychology of different age groups, and we give materials differently to different age children, even if they're the same level of knowledge, like starting level. beginners. And we have materials for more than 5 years of constant education for children. So we have plenty of materials, and our curriculum expands all the time because there is a constant research and development work. We implement best practices of our partners and schools, and our curriculum department remakes it such a way that it can be implemented in our main curriculum, so it expands all the time. And we constantly make new types of equipment and write new blocks for our curriculum. And our curriculum is very detailed. So you can see some samples. The font is little, but just to show you that everything is very detailed. Also, there are some samples on our web page you can look through. So it is written like every 5 minutes what a teacher needs to do. We understand the problem that usually ICT teachers in schools, they don't have deep knowledge only in robotics. But it will be easy for them to understand how to use our curriculum, because it's written step by step. There is an exact guideline what they need to do. And there are like thousands of pages of these materials. And we have an training for teachers. So we understand that our aim is not to make from them great robotic specialists. Our aim is to make from them the parts of our mechanism, the parts of our system. They understand how to use our equipment and how to use our curriculum. And during the first lesson, they just move step by step with this guideline, and they continue studying themselves along with children. And like next steps also, we have some courses to raise their qualification when it is needed, and so on. So we have a highly tuned system taking into consideration like market conditions, so to say. So here are some examples of the equipment, some certificates. Everything is constructed, designed such a way, first of all, it is transparent, it is based on open source, and children understand how it works. So even 3D printer, it's not just a technology that they use to print 3D models. Like this one is a Robbosaurus. But they understand how it works. They understand that it is the same robot. There is the same Arduino chipset inside, there are some mechanical parts, and there is a software that controls these mechanical parts. It's a robot technology that they understand, and what they will be able to make and create themselves further on after they understand it. And so these are our main principles. I can show some of this in my hands. So you can see this Robbo platform. There is an Arduino chipset inside, but on our board. So the concept is to make it as simple as possible, because if you just give Arduino boards that you can buy with all the wires, for most children it will be very boring. They won't understand it. They will lose their interest. They will burn them out. So I have spoken to a lot of schools where this happens in like reality. And they will just, there won't be any result. In our case, we make it as simple as possible, even much more simple than some constructors, because in constructors, they are limited to the functions of that exact equipment. We are not limited to the functions. Maybe like a parent will see that there are only like 3 buttons, but it's not a separate equipment. It's an embodiment of our curriculum. It's a physical part of our curriculum, and it should be used along with our curriculum, where it is written step by step what is needed to be done to achieve a result. So our aim is a result always. So at first step, we take into account psychology of children. They need to get result instantly. So, for instance, a 6-year-old child comes to his first lesson, attaches a sensor to a needed slot. It can't be attached a wrong way because it's on the magnets. So then, like this. Then he chooses this robot in our software, again based on open source language Scratch, but it can be chosen just with one click. Make some logic with a visual programming, moving colorful blocks. So it will take you or me about like less than 5 minutes to achieve. But children will have a result. So it will be simple, like moving 10 seconds forward or just turning left or right. But it will be fabulous for a child that the robot is moving itself. He will achieve this result without any bugs or mistakes that he needs to overcome at first steps. but he will come home and tell his friends or parents that he's a robot maker already. It doesn't matter that he has done nothing, in fact, but he will get this result. And that's how we hook up children. We make it easy for all types of children, and it's interesting for all types of children. But next steps, they understand how it works. They understand what everything means. It's transparent. They investigate the technology. Then they start trying to copy the technology. Then they start inventing, creating themselves. So we have all these steps. So here is Robbo Lab. Different senses can be connected here, and knowledge of some common school disciplines like physics, biology, chemistry can be used in this like robotics projects. And so that's how children start understanding these common school disciplines, this like biology, chemistry, physics better, because they use their theoretical knowledge in practice. Again, there is an Arduino chipset inside, and this equipment can be used not only at first steps. So this can be used further on to make more complicated projects, and it can be something like an MVP for implementing their complicated projects. Like they test their idea, like fresh example of one of our partners. They wanted children, they already had knowledge, they wanted to make a crossroads project. So they took a lab, they are acquainted to this, they know how to get a result without any bugs and mistakes quickly. So they tested the idea, the algorithms, there are some LEDs inside already, and they got an MVP of their project. And the next step, they started thinking how they want to implement it. The way they want to do this. So they took just a piece of wood, draw the roads, printed with a 3D printer, separate cars, the shapes they wanted, and implemented the same algorithm with the Arduino chipset. So we give them the path, exact path, and for the teachers how to lead them, not to make it too easy, not to make it too difficult, to implement their own projects freely. So from one side we give an exact guideline, from other side we give them freedom. So this is our concept. And maybe the last thing that I can show you now, it's like Robot Auto. It's an open source robot. In this case, if this equipment is made in our factories, this one is printed with our 3D printer. You can see the artifacts of 3D printing. So these robots, first they delivered, assembled, they're tested, and they can go run without any bugs and mistakes as well. But at first step, children just play with it. We show them what they will be able to achieve themselves further on, as an example. But first, they just play with it. It's very funny. It can dance like Michael Jackson. It can smile. And it's very good for some workshops or trial lessons. So children, it's just a toy for them at first step. But next step, they can look inside. They understand how it all works. The next step, they can have all these wires, sensors in advance, assemble circuitry. So we have three main educational blocks: programming, 3D modeling, and circuitry. So children can assemble a circuitry, having all these wires in advance. They can print STL files, assemble again this robot, and again play with it. The next step, along with our curriculum, they sometimes understand themselves that they have enough knowledge in circuitry, and they want to make some changes in circuitry themselves, and they make it or add additional sensors. They understand themselves that they have enough knowledge in 3D modeling, and they print it a bit differently or add additional parts. And they start learning some other programming languages. And in some time, they have an insight. So we don't tell them. They come to this idea themselves again, that they have enough knowledge and skills just to go to any shop, buy any electronic parts, assemble a circuitry, print with a 3D printer any shapes and parts. The limit is only their imagination. There can be not only one item with some limits. This can be whole systems, maybe smart homes or whatever they just invent. Assemble all the mechanics and program with a needed language, Python, C++, write a mobile app. So they will have all knowledge and skills. They will have all the tools to start inventing, creating without any limits, implementing their own ideas. And they won't be connected to Robbo anymore. Robbo is only a provider to this high level of knowledge and skills. We have no secrets in hardware. We have no secrets in software, because we are very confident in the value that we give, in educational value. We know how to take a lot of children, make them being interested like in robotics, and make them reach this high level, advanced level of knowledge and skills. So this is our concept. And children understand all these technologies deeply, because even like nowadays there are some educational robots, even in universities, but usually children or students, they learn how to use these existing types of robots, how to program these types of technologies. But our aim is to make children understand it so deeply that they will be able to implement it the way they want it, and start creating the technologies, but not just using them. So one part of our system is a system of different competitions and Olympiads. One of them is a Scratch Olympiad. So we take Scratch because it's an open source language, and nowadays children all over the world usually start their acquaintance with programming from Scratch. And our idea is to make it as simple and as easy and affordable for all the children. So the participation is free of charge in national stage for children, and very simple projects can take part in it. So we give opportunity for all the children to take part in this international event. So the last year there were like more than 4,000 participants from 35 countries, and we've had national stages in 24 countries, along with Ireland. So this is how our national stages and the national stages looked like in different countries. So sometimes like ministers and other governmental authorities participated at these like stages and events. So here's how was it in Vietnam, and our like sample in Thailand. So children of the Scratch Olympiad, they were given prizes from the name of the Minister of Education of Thailand in the cabinet of the Minister of Education of Thailand. And it was really cool. And so also we have tested such a tool like making camps to make children prepare their projects for this Scratch Olympiad. That was an idea of our partner Focus Academy, and I think that we have tested it, and it's a right way to move, and it's a very good direction. And so I think that the next year, like this year, Scratch Olympiad, we have tested it the last year. We know how we need to improve it, and the next year it will be really great. So all the children in Thailand should take part in it. So what to say? We are about serious educational robotics. We are not about playing with robots. And what I was trying to prove you. And I think that's all. And I'm ready for your questions, if you have ones.
Okay, thank you very much, Adil. The great presentation for everyone to understand more about the Robbo system and competition with the Olympic Scratch Olympiad 2023. Right now, we would like to come back.